just do this. So he's busy, and now when we tell him to do this, it waits until he's done. Then it comes back. So that will wait until he's idle, but it's tricky because he can set his idle flag all over the place in different commands. So you have to be careful. So this, God told me to explain crosstalk with wait. Now this is one of the, there's a huge number of routines in the printf family. All these routines have format and arguments. And the reason is because it's really easy and nice doing ... functions. I don't know what they're called, variadatic. Let's just call them ... dots. Anyway, so when you do a ... in TempleOS, you know how in C++ you have a this variable? Where does the this variable come from in C++? It's an invisible variable, isn't it? Well, in Holy C, you have two system variables, argc and argv, and they should be immediately obvious what they are. So I went ahead and made my my print join. That's basically what they funnel into. It takes argv and argc. So this, if you tell it null, it mallocs a huge, as big a buffer as necessary to hold the printf string. So this will hold any size. This, if you do null, this returns an allocated string. We don't worry about buffer overflows. We just crash. So seriously, people think that's funny, but we want simple code. And you know, if somebody wants, it's like a motorcycle. If you tip over on a motorcycle, it crashes. Don't do that. That's just what you don't do. And it's really ugly to have to put an overflow check every single time you use a buffer. So we don't have any overflow checks. And if you have a limit, that just sucks, because you always hit the limit, don't you? Whenever you have an overflow, you have to, sometimes the limits are ridiculously low, but we just crash. It's your machine 100%, so if you want to use up all the memory, that's your option. This is not a server with other users. It's your computer. Anyway, so this allocates a string, and then what do? We get a little bit fancy here. We do now we call this is memory string alloc. It's the same thing. What do? We tell it to we put it in quotes, so it's going to print it. This gets tricky, doesn't it? What the hell is this? Then we print it, and then we free. Okay. So we're getting tricky here. This string is on our heap. This string is on our heap, and we want to free it in case. Now, if we die, that leaves it stranded. In the other task, well, that's an example of don't do that. Anyway, don't die. Don't die. Actually, as a matter of fact, it's not quite, we're not giving it this string, we're giving it this string, as a matter of fact, but it's the same difference. We could allocate off of his heap. You know, maybe I should do that. It gets a little tricky. We can allocate off of his heap, but I don't care. We could do that. All tasks are on the same address map. So that's, yeah, I guess I kind of screwed up, didn't I? It should be on his heap. But it gets ugly because then I have to deal with the length. Anyway, so what are we doing? We're sending text. Oh, I know what it is. Okay, so the when you send text, how do I put this? It's an auto file, and what an auto file is it's a pipe. It's piped through a task, and so the output goes to standard. The output of the auto file goes to standard in, and the input of the auto file comes from the source. Anyway, basically this is a pipe task. It's an auto file. So we can review this elsewhere. Long story short, we put it in his buffer, and then we free when we have printed it. So we don't stick around very long. We could die, it's true, but when he processes it, he makes a copy of the whole thing. If it's big, he makes a big copy. That's just life. And then we free and then we wait for him to be idle. This is a really simple operation here. Tasks have an idle bit. As long as he hasn't been killed, he's still valid and he's not idle. Oh, we also check if he has a command in his buffer, so it's a little bit safer. So if he's got commands in his queue, or he's not idle, it's kind of voluntary when you mark yourself as idle. Anyway, and it happens periodically. When you print something to the command line, it might idle for a second. You have to be careful. I don't remember, but it yields the CPU. Maybe it doesn't go idle. It just yields the CPU. Anyway, so we can talk about auto files. So these are auto strings. Auto is just raw text that's been. The auto string, this is what I'm talking about. This is an auto file is a mini program. Here's what an auto file is. An auto file is a mini program that standard out goes to standard in. So if we do this, if we say auto, let's move this. I'm going to move this to AUT, and then I'm going to do a directory. Now I go auto file, and he did that directory. Now if he gets an input, he does not pass that on to the this is like a pipe, and he's in front of the slave. So it's going to wait for this master to. So now we're going to do this auto file. It's going to wait for me to press a key, and then it's going to do the second one. Does a directory. Now we're waiting. Now I'm going to press a visible character. Oh, it did it. That's too bad. That's not what I was expecting. It echoed it. Well, I guess that's normal. Yeah, that's what it should do. The other answer. Okay, so we say comma false. It's not a problem. I was just disappointed. Oh well. It's the right answer, don't worry. All's well. Now I hit T. It doesn't echo it, and it does the directory. Okay.